Remember this picture? We have the positive ends of leads 1, 2 and 3 with the negative ends of leads 1, 2 and 3 as well. And today we're just going to look at what happens to lead 2. So we can superimpose a picture of the heart onto this picture here and say, well, we made a vector that looked a little bit like it was going in that direction. So we literally just stick that vector from the center of this little diagram downwards in the exact same direction it was going in before. So again, how does that link to the ECG? Well, because it's pointing towards the positive end of lead 2, on the ECG trace, it goes up. When this vector points towards a positive lead, it goes up. Another way to look at it is another way is that if a vector is pointing towards the negative end of a lead, and you can see it here pointing towards the negative end of lead 2, it causes a downstroke. And the size of this arrow that we can see here is proportional to the length of this line here. So we can see that the point where this arrow crosses lead 2 will be a line that's perpendicular to it. It's about here. Whereas if we look at this next slide here, the arrow is slightly smaller. It's still negative, but it crosses the line at this point rather than this point, which means there is still a negative line here, but it's just not as big as it was before. So what we're going to do now is go through the QRS complex, or the ventricular depolarization, piece by piece, and see what vectors make up the QRS complex, and let's see how each vector makes the QRS look the way it does in different leads.